Welcome. Today, we're diving into one of the biggest, most fundamental decisions you can make in technology, picking the right database. Whether you're building a tiny app or a massive global system, this choice is going to define pretty much everything.
So, choosing the right database, yeah, it's way harder than it looks. You've basically got two major camps, SQL and NoSQL. And believe me, picking the wrong one, it can lead to some serious headaches. We're talking slow performance, scaling nightmares, the works. So how do you get it right?
So, here's how we're going to break it all down. First, what even is a database? Then we'll jump into SQL, the world of structure, and its rebellious cousin, NoSQL. After that, we'll get into the really juicy part, the fundamental trade-off between them. And finally, we'll wrap up with how you can make the right choice for your project.
All right, section 1. Let's start at the very beginning. Before we get into the whole SQL versus NoSQL debate, we've got to be on the same page about what a database even is. And really, at its heart, it's that simple. Just think of it like a super smart digital filing cabinet. Its entire job is to take your data, keep it perfectly organized, and then retrieve it instantly whenever your app asks for it. Sounds simple, right? But it's unbelievably powerful.
Okay, let's get into the first contender, SQL, or Structured Query Language. For decades, this was pretty much the only game in town. It's the established order, the reigning champ of the database world.
The best way to think about SQL? It's basically like a spreadsheet on steroids. Everything is organized into these neat tables with rows and columns. Every single piece of data has its own specific little box to live in. And that rigid structure, that's actually its biggest strength. It's all about order, predictability, and knowing exactly how all your data connects.
So how does it enforce that structure? With something called a schema. You can think of the schema as a blueprint, or maybe even like a strict contract for your data. Before you can add any information, you have to define the rules. You have to say, okay, a customer record must have a name, an email, and an ID. That way, every single entry is guaranteed to be consistent.
And this all leads to SQL's main selling point, rock-solid reliability. This reliability is guaranteed by 4 key properties we call ACID. Think about something like a bank transfer, right? You need that transaction to be all or nothing. You can't have the money leave your account but not arrive in the other. It has to be perfectly consistent and durable, meaning it survives even if the power goes out. That's the ACID guarantee, and it's exactly why things like financial systems are built on SQL.
But then, the internet happened. Big time. Suddenly we had social media, billions of connected devices, just a massive explosion of data that didn't always fit into neat little boxes. That rigid SQL structure started to show some cracks. We needed something faster, more flexible, and built for massive scale. And that need sparked a revolution called NoSQL, which, literally stands for not only SQL.
Now here's the thing. NoSQL isn't just one type of database. It's more like a family of different approaches. The first type is called a document store. Instead of rows, data stored in flexible documents, kind of like a JSON file. This means every record can have its own unique structure. Think about a product catalog. A t-shirt has size and color, while a laptop has RAM and CPU. A document store handles that perfectly.
Then you have key value stores. This is probably the simplest model of them all, and because of that, it's often the fastest. You just have a unique key, say a user ID, and then a value attached to it, like all the items in their shopping cart. They are built for one thing, ridiculously fast lookups.
All right, next up are column family stores. These ones are kind of mind-bending at first. They store data in columns instead of rows. I know, it sounds weird, but it's an absolute game changer for big data analytics. Imagine you have a billion rows of data, but you only care about the total sales column. With this model, the database only has to read that one column, which makes the whole process unbelievably fast.
And last but not least, we've got graph databases. These are custom-built for data that's all about connections and relationships. The classic example is a social network, right? You've got people who are nodes, and they're connected by relationships like is friends with or likes a post. A graph database is designed from the ground up to map out and query those complex networks.
Okay, so now that we've met the players, this brings us to the fundamental trade-off. This is the core philosophical difference between SQL and NoSQL. Because when you start dealing with data distributed all over the planet, you quickly realize you can't have it all. You're forced to make some tough choices.
And here's the big question at the heart of it all. Let's say your database is running on servers in New York, London, and Tokyo. Can you really guarantee 3 things at once? 1,
perfect consistency, meaning everyone sees the exact same data at the exact same time. 2, 100% availability, meaning the system is always online. And 3, it can survive a network failure, like the connection between London and Tokyo going down.
Well, it turns out the answer to that question is a hard no. You can't. And there's a famous computer science principle called the CAP theorem that explains why. It basically says that in a distributed system, you can only pick 2 out of those 3 guarantees: consistency, availability, and partition tolerance. And since network partitions, failures, are a fact of life, you're really forced to choose between consistency and availability.
So let's say you choose consistency over availability. You get what's called a CP system. The system's number 1 priority is making sure the data is always correct. So if there's a network problem and it can't guarantee that the data is 100% accurate, it will literally stop responding. It prefers to be unavailable than to give you wrong information. Makes sense for a banking system, right?
Now, what if you make the other choice? You prioritize availability. That gives you an AP system. This system's main goal is to always be online no matter what. So during that same network issue, it will keep serving requests, even if it means some of the data might be a little stale or out of date. The idea here is eventual consistency. It'll all catch up in the end. A perfect example is your social media feed. It's not the end of the world if a like takes a few seconds to show up everywhere.
Okay, so we've got SQL with its strong consistency and NoSQL often leaning towards availability. With this huge trade-off in mind, how in the world do you actually choose the right one for your project?
Well, it really just boils down to this. What are your priorities? If your data is structured, if you absolutely need those ACID guarantees, and if consistency is non-negotiable, you go with SQL. But if you're dealing with massive amounts of data, your schema needs to be flexible, and speed and availability are your top concerns, then NoSQL is almost certainly your best bet.
This table here is basically the ultimate cheat sheet for this whole debate. It lays out the key differences side by side. You've got the schema, fixed and rigid for SQL, flexible and dynamic for NoSQL. You've got scaling. SQL typically scales vertically, meaning you buy a bigger, more powerful server, while NoSQL scales horizontally by just adding more servers. And of course, consistency, strong in SQL versus eventual in NoSQL. And honestly, if you only remember one thing from this whole explainer, let it be this: there is no winner here. This isn't about which database is better overall. It's always about which one is the right tool for the specific job you're trying to do. In fact, if you look at how most modern, large-scale systems are built, they don't pick one, they use both. It's a strategy called Polyglot Persistence. They'll use a rock-solid SQL database for the super-critical stuff, like user accounts and financial transactions. And then they'll use a speedy NoSQL database for things like a real-time social feed or a product recommendation engine. It's the best of both worlds.
And that really brings us to the final, most important point. The real question today isn't SQL or NoSQL. It's how can we use them together? It's about looking at this amazing toolbox we have, understanding what each tool is best at, and then combining them to build applications that are more powerful and more resilient than ever before.